All right, let's solve some exponential and some log equations. So here's a logarithmic equation. It has a log in it. So our strategy is going to be to just isolate the log expression. So we want to get this part by itself. Okay, so that's pretty simple to do. I'm just going to subtract 7 from both sides. That will leave me with 10 times log base 2 of 3x plus 4 equals 50. Then I can divide both sides by 10. I'll get log base 2 of 3x plus 4 is equal to 5. All right, once you get the logarithm isolated, just use the definition of what log means. So this means 2 raised to the 5th equals this. So 2 raised to the 5th power is 3x plus 4. Right, then simplify. 2 to the 5th is 32. Now you just have a nice simple linear equation to solve. So I'm going to subtract 4 from both sides. Get 28 is equal to 3x. And my final answer would be 28 over 3. All right, so we can check that. 28 over 3, plug it in for x. 28 over 3 times 3 is just 28. 28 plus 4 is 32. Log base 2 of 32 is 5. 10 times 5 is 50. 50 plus 7 is 57. All right, let's solve exponential equation this time. So here I have an exponential equation. My variable is in the exponent. So the same strategy as on the last problem. I'm going to isolate the exponential expression. So I'm going to get 2 raised to the 3x plus 1 by itself. Okay, so first step, I'm going to add 7 to both sides. That'll leave me with 2 raised to the 3x plus 1, all divided by 4 equals 8. Now I can multiply both sides by 4. That'll give me 2. 3x plus 1 is equal to 32. All right, now comes the fun step. How do I get the x out of the exponent? So I'm going to do the inverse process. Remember, the inverse process of exponentiating something is taking the log of it. So I'm going to do log base 2 of both sides of this equation. So now when I do that, okay, I have log base 2 of 2 raised to the 3x plus 1. So 2 raised to what power gives me 2 raised to the 3x plus 1? Well, obviously that's going to be 3x plus 1. 2 raised to the 3x plus 1 is equal to 2 raised to the 3x plus 1. Right. On this side, I have log base 2 of 32. That's 5. It's equal to 5. Now we can subtract 1 from both sides. 4 divided by 3, and I get 4 over 3. Let's check and see if that really works. So if I put 4 over 3 in for x, 3 times 4 over 3 is 4. 4 plus 1 is 5. 2 to the 5th is 32. 32 divided by 4 is 8. 8 minus 7 really is 1, and we got that correct. All right, right here, notice I set this problem up so that this worked out. We knew what log base 2 of 32 was. But what if we'd gotten maybe a 7 right here, log base 2 of 7? You wouldn't know exactly what that number was. You could ask your calculator to give you an approximation to log base 2 of 7. But for our purposes, if you get something that doesn't work out, just leave it at that. So had this been log base 2 of 7, you would have just left log base 2 of 7 right here and just finished out the problem with that number. All right, let's try one more example. So again, I'm going to isolate the exponential expression. So I want to get this by itself. All right, so first step is to subtract 2 from both sides. That would leave me with 5 times e to the 3x minus 4 equals 8. Now I can divide both sides by 5. So I get e raised to the 3x minus 4 is equal to 8 over 5. All right, how to solve for x now? I have an x up in the exponent. So the same strategy as before. To undo an exponentiation, I'm going to take the log. In this case, I'm going to do log base e. Log base e can be abbreviated as ln for natural log. So natural log of both sides and the natural log of this side. All right, so I have log base e of e raised to the 3x minus 4. So e raised to what number gives me e to the 3x minus 4? Obviously, that's just 3x minus 4. So I took the appropriate log of both sides in order to get this variable out of the exponent. All right, I have no idea what the natural log of 8/5 is, so we're just going to leave it as the natural log of 8/5. And then we'll finish solving that out just in time because my marker is about to go dry. I'm going to add 4 to both sides. So 3x is equal to the natural log of 8/5 plus 4. Now, final step, I'm going to divide everything by 3, and I get x is equal to the natural log of 8/5 plus 4 divided by 3.